Today we check out the project scheduling. Now we know that the project management is important, strategically important for the corporations. And it is also very important for individual employees. Now, what is project management all about? Project management want to achieve the projects, to finish the projects on time, on budget, with quality output. It involves team organization and scheduling. In other words, schedule the sequence of activities and the resources. And this two part, the planning and the scheduling, is work up front before we start the projects. When the projects are ongoing, we need to control it. We need to monitor the time, cost, and quality of output. In this session, we focus on the hardcore part of project management, which is scheduling. And it involves scheduling the sequence of activities and resources. Here's a list of the questions we can answer by using the project scheduling technique. For example, when will the entire project be completed? So we have to look ahead. And what are the critical activities that will delay the entire project if they're late? So we need to identify the critical ones and we need to focus on them. And what are the non-critical activities? Those ones that can run late without delaying the whole project's completion. Now, those are the ones we can pay less attention to. And at last, what is the probability that the project will be completed by a specific date? Usually we have deadlines. Now, what are the chances the project can be completed? We need to answer all these questions when we start our project. The basic technique we use is critical path method, or CPM, developed by DuPont for chemical plants in 1957. Also, the Booz Allen and Hamilton with the U.S. Navy in 1958 developed a technique called the Program Evaluation and Review Technique, which was developed in 1958. They're different terminology, similar objectives, similar techniques. Later on we are not gonna distinguish between these two. Here are the steps for PERT or CPM. Basically, the technique we're using. We have 4 steps. We're gonna use the a example to learn these steps. Here comes the example. Milwaukee General Hospital was recently required by the Environmental Protection Agency. They were given 16 weeks to install a complex air filter system in its operation facility. Now, Milwaukee General Hospital identified 8 activities that need to be performed in order to complete the project. Here is the list of the activities: building the internal components, modify roof and floor, construct a collection stack, pour concrete and install frame, building high temperature burner, install pollution control system, install air pollution device, inspect and test. So we give them a name. We call them A, B, C, D, E, F, G, H. So we have 8 activities here. For each activity, there is a immediate predecessor. What is an immediate predecessor? For example, activity C. In order to start activity C, we have to first finish activity A. In other words, if activity A has not been finished, we cannot start activity C. Another example, D. Activity D has two immediate predecessors, A and B. It means activity D can only be started after activity A and B have been finished. Okay, so we call that immediate predecessor. Let's look at A and B. We don't have any immediate predecessor here. That means activity A and B do not rely on other activities. They can start on their own at any time. Here is a list of the activities. Building the internal components, modify roof and floor, construct collection stack, pour concrete and install frame, building high temperature burner, install pollution control system, install air pollution device, inspect and test. So we give them a name. We call them A, B, C, D, E, F, G, H. So we have 8 activities here. For each activity, there is a immediate predecessor. What is an immediate predecessor? For example, activity C. In order to start activity C, we have to first finish activity A. In other words, if activity A has not been finished, we cannot start activity C. Another example, D. Activity D has two immediate predecessors, A and B. It means activity D can only be started after activity A and B have been finished. Okay, so we call that immediate predecessor. Let's look at A and B. We don't have any immediate predecessor here. That means activity A and B do not rely on other activities. They can start on their own at any time. The next step is to build up the activity network when we have identified the activities and the immediate predecessors. The reason we draw such a network here is because it's more straightforward visually comparing to a table like this. Essentially, this table and this network give us the exactly same information. Let's see how we build up this. Now, if we look at this, we start from the end, right here, instead of the start. We look at the table, we identify the last activity. That means the last job we do among all those activities. Now here is the H. So we draw a circle and write H. And then what are the immediate predecessors for activity H? It's F and G. So we draw F and G, two circles, and draw one direction arrow from F to H and from G to H. So the arrows shows the relationship between F, G, and H. Okay, now we look at F. F is right here. F has an immediate predecessor C, so we draw a C here. And do we have any other immediate predecessors for F? Nope, the C is the only one, so we draw a arrow from C to F. Another one is G. What is the immediate predecessor for activity G? D and E. So we draw circle D, E, and we draw arrows link from D, E to G. Then E has a immediate predecessor C. So from C we draw an arrow to E as well. So we finish this graph, and when we get to A and B, we know that these two activities do not have any immediate predecessor. So we draw a rectangle and write a start here. So that means A and B can start anytime we want. In order to start C, we have to finish A first. In order to start D, we have to finish A and B first. So this whole thing, we call this activity network. For each activity, we can estimate how much time it needs. For example, A here, activity A, we estimate it needs 2 weeks. B, we estimate it needs 3 weeks. And the total for A, B, C, D, and E, F, G is 25 weeks. Now here comes one question for you to ponder, to take a moment and think about it. Here comes the question. Do you think that this project will need 25 weeks? So please stop the play and think about this for a moment. When you're ready, please move on to the next slide. Now, let's work on the activity network. We have the activity network already, okay, as we have done. Now, for each activity, we know that we estimate the time for it. For activity A, estimated time is 2 weeks. So we put a 2 on top of this little circle here, on top of A. We put a 3, which is estimated time for B, on top of B. So we do the same thing for C, D, E, F, G, H. And the start and end is just a label here. It does not have any time.